MySQL Replication is a best-known AJ solution for MySQL, I guess, and the pool basically showed it also today. And the main point is that we can use it also for scaling, so it's like 2-in-1 solution. By default, it's asynchronous. Of course, we can switch to semi-synchronous replication to ensure that there will be no data loss in case of failover. Failover process in MySQL Replication is somewhat tricky without global transaction ID. Global transaction IDs help a little bit, but not that much. What's good is that there are many tools that are available to automate this process, and we will discuss one of them later today. So the failover process basically looks as follows. So for starters, we have to locate the most advanced slave. So the slave which is the most in sync with the master. If master binary logs are available, for example, the MySQL died, but the server, the host, is still available and reachable by SSH. In that case, we should check the binary logs, parse them, and ensure that we apply any missing transactions on the chosen slave. Then we need to ensure that all the slaves are on the same position for the slaving. So we have to parse the binary logs of this new to-be master the slave that we chosen earlier, and then apply and then go over the remaining slaves and apply any missing transactions there. Once that we need to reslave those slaves to the new master and perform the failover by either moving virtual IP or changing some DNS settings or something like this. The whole process is error-prone and it's tricky, especially error-prone when you are doing it, under the pressure, under the stress. And if you are performing a failover on production server, then you are doing it under the stress and pressure. So what's good is that you can use some tools, as we mentioned, and MAJ is one of them, which we will cover later, to manage the failover process for you. Global transaction ID helps us to a little bit here because the slaving parts becomes much easier. Basically, what you need to do, you can use master auto position equal to 1, and the slaves will connect to the new master. They will ask for any missing transactions, and you don't have to ensure that they are all in the same position. You don't have to apply those binary logs here. So this part is easier. But you still have to choose the most, the most advanced slave to promote to a new master, and you still have to, parse the binary logs on the master if they are available, and apply those missing transactions to the new master. So you still may benefit from some additional tooling to automate and to speed up this process. And the MAJ is the tool for that. It basically handles this whole failover process for you. It does all those steps that I discussed earlier. It can be used both as a standalone solution, or it can be used as a part of some other clustering solution, like, for example, Pacemaker. Master AJ _ manager script, if we are talking about standalone solution. The master AJ manager script will be a single point of failure here, so you have to monitor it, with a great deal of details to ensure it's up and running all the time. This script basically, its job is to monitor the replication topology and trigger a failover if it's required for some, given the configuration. So without it being, if it's being down, then the failover may not happen. So that's a significant problem here. MAJ can work with both global transaction ID and with regular replication, so it's pretty flexible here. And what's really important to keep in mind, and this is something we will repeat a couple of times in this webinar, is to make sure that you have a shutdown script defined. I mean, the shutdown script is a variable in MAJ config where you pass a path to a script that will perform the other node in the head process. Basically, the script is supposed to be executed during the failover, and it's supposed to ensure that the old master will stay down, because otherwise it could be a problem. It can create some problems. Clustering, I guess, is the ultimate solution for the high availability. In MySQL world, we have, well, probably more, but the most popular ones are two clusters. MySQL Cluster is one of them. It's a synchronous cluster. So basically, all the changes, all the modifications happens at once without delay. It's based on a DB engine. So you have to keep in mind it is not InnoDB, and it causes, it makes it harder to actually implement. MySQL Cluster delivers great point select performance. We're talking here about primary key selects, unique key selects, this kind of queries. It provides great insert performance for simple quick inserts. It uses for the redundancy. It uses data partitioning. So basically, it has you have some number of data nodes, and the data is located across the data nodes in a way that there are always two copies of a given row in a whole set of data nodes. And this is it causes that MySQL Cluster behaves differently than InnoDB, especially for range queries, because the point here, if you are running some kind of range query, let's hundreds of thousands of rows, for example, but even smaller ones too, then basically you have to grab data from multiple data nodes. You have to move this data over the network to a single server, SQL node. You need to actually combine this, aggregate this data. You need to execute the query. You need to generate the result set, and it's basically additional work to do for those moving this data over the network. It's definitely not a drop-in replacement for regular MySQL. So it's a really great solution, but if you plan to use it for application, you'll need to really ensure that your application will fit in the work, in the workload type where the MySQL cluster shines, because otherwise you can run into serious problems here. Galera Cluster is the other very popular type of a cluster in MySQL. It's a virtually synchronous cluster. It's basically almost synchronous cluster. For most of the time, for small write sets, the lag would be like a few milliseconds, barely noticeable at all. And Galera Cluster doesn't speed the data like MySQL Cluster do. I mean, it's so each node has a full copy of the data. On the one hand, it's somewhat harder to scale because for MySQL Cluster, if you add some more data nodes, you increase the disk to memory to disk ratio, and it allows you to keep more data in memory. Here, you can do this. You just have to either invest in larger hardware or in memory, or basically you will probably need to invest in faster disks. But on the other hand, it's advantage of the Galera cluster because you have all the data in a single place. So the reporting queries, all those joins, 5 across multiple tables, will probably work better because the data is available locally. There's no need to move anything over the network. Galera cluster, I would say, is almost a drop-in replacement for MySQL. It uses InnoDB engine. It performs somewhat similar, but still there are some differences. For starters, there is a difference in auto-increment handling. it's very likely that you will see gaps in auto-increment columns when using Galera Cluster. All tables should have a primary key defined, which is true for InnoDB also, but for Galera it's even more true, as I've seen both performance problems and crashing bugs caused by tables which didn't have a primary key defined in it. It is InnoDB only, basically. I mean, there's an experimental MySQL support, but do not use it. Apps transactions may be problematic or even impossible to execute. There is a fixed limits. There are fixed limits on both transaction size in terms of gigabytes. If I remember correctly, it's 4 gigabytes. And also there's limit on the number of rows per transaction, modified per transaction. So I think it's 1 million max. So large transactions you may need to split in batches or something like that. Schema changes also may become more complex due to the way the Galera cluster handles them. And of course, it's a virtually synchronous cluster, so write performance will differ from regular MySQL. It will be slower most of the time. Okay, so now we will talk a little bit about the proxy layer, but first I think that JJ has a poll.
Yeah, thanks very much, Christoph. And let me just start this poll. We just want to ask you another question, and it's related to the next topic that Christoph is going to start talking about just in a minute. And it's just to have an understanding of which proxy you use today yourselves in the audience, whether it's HA proxy, MaxScale, proxy SQL, MySQL proxy, or some other proxy. It'd be great to know which one it is that you're using, just to give us an idea of the distribution across the audience today. So thanks for participating in this poll. I'll just give it another few seconds for everyone to participate. And thank you to those of you who are asking questions in the question section. Feel free to ask us more. Those are good questions there already, and we'll answer them towards the end of the session. Great. So thanks for participating. I'm just going to close the poll and share the results. So not too surprisingly, a lot of you are using HA proxy. It's a very popular proxy, especially amongst the MySQL user base. It's nice to see some MaxScale users as well. That's a new proxy that Christoph will talk about, of course, by MariaDB, and then there's MySQL proxy. I don't know if you have any comments on this, Christoph, before I hide the results.
Yeah, I mean, I think that's basically what I expected, because AJ Proxy is really popular tool out there, and you can achieve build a very nice proxy layer using AJ Proxy and some custom scripting, which we'll cover a little bit later today. So yeah, I guess that's basically what I would expect. And I agree, it's really nice to see MaxScale users, because I mean we've been waiting for a MySQL our proxy for a while, and yeah, I'm not surprised that people are willing to test it and to actually see what kind of features it can provide.
Great, thanks, Christoph, and I'll hand back over to you then.